All right, welcome everyone to 10.3a. Today we are going to add and subtract radical expressions. So we're going to add and subtract radicals. Okay. All of our rules about simplifying our square roots are kind of come back into play today. We won't have any multiplying and dividing because we will be adding, subtracting, but we will have to simplify. So we will need to know our perfect squares again. Real quick, let's do these two final review problems because reminder, we are getting ready for our final. This one said that we have to solve for our x's. Reminder how many x's there are, that's how many answers you will have. I see I have this first parentheses here, and we're going to set them each equal to 0. So I'm going to say x plus 12 equals 0, and we will say 2x minus 10 equals 0. And then from here we will solve both of these. This first one I'm going to subtract 12 from both sides. So our x will equal negative 12. This one we had to do two steps. I'm going to add the 10 to both sides. And then we're going to divide by 2. So this x is going to equal 5. So reminder how many parentheses or how many x's you have, that is how many answers you have. And you will set them both equal to 0. All right, this next one, we are going to factor. Now reminder, this is our tricky factoring because there is a number in front of our x squared. Reminder, when we do these, we're going to list all of our multiples for our number in front and our number in back. So to get to 2, we have 1 and 2. To get to 6, we have 1, 6, 2, and 3. So we're trying to multiply these to have a combination to get to 12, or I'm sorry, to get to 13. We do see if we times 2 times 6, that gives us to 12, so that gets us really close here. So 2 times 6 gives us 12, 1 times 1 gives us 1, and if we add those together, we get 13. So we're going to be using this multiple and this multiple to help us factor. So I'm going to plug the 1 and the 2 in first. So I'm going to have my 1x or x and my 2x. Reminder, we multiplied the 2 to the 6. So I'm going to put the 2 is multiplying to the 6, so it needs to go right here. And we multiplied the 1 to the 1, so the 1's going to go back here. Notice everything's positive, so that means we're going to have a plus and a plus. All right, so on your final, you are going to have some problems like that. All right, let's get into what we're doing today. Today we're going to add and subtract radicals. So when we're talking about this, these are going to be similar to things that we've done before. So on this first problem, I have 3x plus 5x. So they are like terms. So reminder, we just add the coefficients or the numbers in front. And so I'm going to take 3 plus 5, and that's going to be 8. And reminder, we don't do anything to the x's. You're just going to say 8x. It's like I have 3 apples plus 5 apples, and we now have 8 apples. You wouldn't say apples squared, we just have apples. Same with down here. I notice these both have a square root of x and a square root of x. So therefore, we're going to add our two front numbers. So I'm going to take this 3 plus this 5, and we are going to have 8 square roots of x. So again, just noticing, we're really just doing stuff with that number in front. The stuff in back, we don't really do anything with that, okay? So today, to be able to add or subtract radicals, reminder, radicals means square roots. So to be able to add or subtract square roots, you must have like terms. Okay, so what that means is the radicand, or the stuff under the square root, must be the same. Okay, so everything inside the square root must be the same. So the numbers, letters must be the same. So if we look here, I have a problem worked out for us. So if I start here, I see that all of my stuff inside the square root is not the same. So then we're going to bring back something we've done before. We're going to do that simplifying radicals. And reminder, that's when we split it between a perfect square and a non-perfect square. And we're going to do that until our numbers are the same. And then we're able to combine like terms. So then we do what we did up there, and we look at all of these numbers and we combine them. We're looking to make sure we see the signs. So notice that 3 is negative, so that 3 we actually subtracted it. Okay. All right, so let's go try this out on the next page. So as you can see here, some of them have the same number in front or inside the square root, and some of them do not. So on our first 4 here, these are when they are like radicants or like numbers inside. So on this one, they both have square roots of 11. So we can just bring that down right away that we know we're going to have the square root of 11. And then we take our numbers in front. So I'm going to take 6 plus 9. And when we add those together, we're going to have 15. So we have 15 square roots of 11. There's nothing else we can do with that problem. So we are done. This next one in the top right corner, we see they both have the square root of 3. This one, there's no number in front, so there's really a 1 there. Okay, so square root of 3, we're just going to bring that down, and then I'm going to take 1. Notice this time it's a minus, so I'm going to take 1 minus 4, or I'm sorry, 1 minus 5. And when we do that, we are going to have negative 4. Again, don't do anything to the 3, and we are done. So as you guys can see, when they are like radicants, numbers in the square root there, they're much easier to do. This one, they both have the square root of 2, so we can just bring that down. And we have 7 minus 8 in front here. So I'm going to subtract those, and we're going to have negative 1. You could write it like this, or you could also just write it like this with no 1 in front. They are both the same thing. Okay. Last one, real quick, they both have the square root of 5. So we're going to bring down that square root of 5, and then we're going to add the 5 and the 2, and we're just going to get 7. All right, so as you guys can see, when they are like terms, they are way easier. Now let's look at these next two, which do not have like terms. So this is where it gets more complicated, but luckily we've done this stuff before. So reminder, what you're going to do first is you are going to simplify. Okay, reminder, that's when you're looking to split it between a perfect square and a non-perfect square. Okay, I'm just going to write some of our perfect squares just because we haven't talked about these in a little bit. So I'll just list a few of them here, and hopefully it's jogging your memories, and maybe you have them written somewhere already in your notes. Okay, so I'll just write down those for right now. All right. So as you can see, we have 7 and 28. Those are not like terms, so we can't really do anything with that. 7, I'm looking at 7. None of these perfect squares goes into 7, so I'm just going to bring that one down. That one, I can't simplify it. This one, though, 28, I can split that one. I'm going to split it. I hope everyone sees 4 goes in there, so I'm going to split it between 4 and 4 times 7 gives us 28. And I think we're about to see what's going to happen because they both now have a 7, so that's going to help us later. Reminder, the square root of 4 is 2. Now I need everyone to notice we do have a 2 in front. So what we have here is 2 times 2 because that square root of 4 becomes 2, and we have that 2 out in front. Square root of 7, we can't do anything with that, so we're going to still have the square root of 7. We are going to have 2 times 2 here, so that will give us 4. Oops, sorry. Over here we still have this. This one's boring. This one's still the same. 4 square roots of 7. This one, the 2 times 2, that's going to become 4 square roots of 7. And now it's like the problems we did above. They both have the square root of 7. So we're going to take 4 plus 4, and that's going to give us 8 square roots of 7. Okay. Now this next one, again, we see we have 32 and 18. I can't combine those because they are not like terms. Now both of these we can simplify. Our 32 here, 16 goes into 32. So I'm going to split 32 between 16 and 2. Okay. The square root of 16 becomes 4. We do not know the square root of 2. And a reminder, we have that 5, so we are going to bring that down. So we do have 5 times 4. And when we do that, we have 20 square roots of 2. Now I want everyone to look at this. We see we have a square root of 2 on this one, so that probably means square root of 2 is going to be in this one as well. So 18, we can split that between the square root of 9 and the square root of 2. So as you can see there, we're getting a 2 there, which will help us for later. The square root of 9, that's going to turn into 3. We don't know the square root of 2, so that's going to stay in the square root. We have this 4. I need everyone to notice there is a negative there, so we're going to bring down negative 4 in front here. And negative 4 times 3, that's going to give us negative 12. And the square root of 2. Now that they both have the square root of 2, we're going to take our front numbers, combine them. We have 12, or I'm sorry, we have 20 minus 12, which is going to give us 8 square roots of 2. And there we go. So today you are going to have problems like the ones above, where you have like terms and you're just going to take the numbers in front and add or subtract them. You might have some like these where you'll have to simplify first and then add or subtract them. Okay, so reminder, the only way you can do this is if your square roots are the same. All right, thank you and good luck.